But I think at the end, most centers will deploy a solution like this, and REGALE really provides the foundation for the European systems to have this in place and with them make them viable for the future.
My name is George Brumas. I am an associate professor at the National Technical University of Athens and an affiliated researcher at the Institute of Communication and Computer Systems. I have the honor and responsibility to coordinate the REGALE project.
My name is Martin Schulz. I'm at the Technical University of Munich. I lead the chair for computer architecture and parallel systems, and I'm the technical lead in the REGALE project.
REGALE is motivated by two important facts relevant to the operation of modern exascale supercomputers. The first fact is that modern supercomputers are a hungry energy consumer, which means that energy efficiency is a key important target, equally important as performance. The second fact is that current and next generation applications running on supercomputers are not anymore the traditional simulations that were running on these facilities for decades, and they were implemented by, let's say, superhero code developers. Now we have more complex workflow-based applications that are implemented from new domains, from artificial intelligence and high-performance data analytics. In these cases, in these domains, we cannot always expect that the developers have the appropriate skills to run and optimize their code on these large-scale facilities.
There's been a lot of work in the last decades on reducing energy consumption in the hardware. There's a little bit done on the software level, but I think we can do more on the software level, and that's exactly where REGALE attacks on. We are working on several components that can manage energy, they can manage energy consumption, and that's exactly the components we're developing with REGALE. More precisely, we're taking existing technology from various partners that have been developed, we're putting them together, we're making basically one large system out of this that can work together, that can really deal with large-scale systems and provide energy-efficient solutions. Basically, we can classify the partners into three groups. For one, we have partners that deal with energy-efficient solutions on the low level at the runtime level. We have also seen that we can do it better if we integrate workflow solutions into that as well. That gives us some information from the application directly into the runtime system for free, basically. So we have a set of partners that develop sophisticated workflow solutions. And as a third group, we have application partners in there as well, which provide us with pilot applications and test the solution from bottom to top, and not just provide some benchmarks, some results, but we can actually show that this works for real-world applications. And in this project now, the goal is to take the solutions from the low-level runtimes and the workflow solution, put it together, build a common system, and then make this available to the applications and test it with the applications.
Towards the end of the project, we are putting our effort in order to deliver a prototype system that will be mature enough to be directly exploited after the end of the project. We will also deliver 5 applications integrated with workflow engines, applications that come both from traditional and new domains relevant to supercomputing. Of course, in the final phase of the project, we would like to raise the awareness of stakeholders for the findings and accomplishments of REGALE so that we maximize the project's impact.
In the remaining time of the project, we really want to build prototypes. We want to make this work on real systems and provide real results with real applications. So we have a system that then can hopefully be put into a production system and deployed on systems in Europe, particularly on the Euro HPC systems.